Hi everybody, I'm Alex Bradbury. I'll be talking about, or giving a brief overview of recent activities with RISC-V, a very whirlwind tour of what's been going on recently. I should say I'll be talking more about low risk, which I've talked about at previous ORConfs tomorrow, so you can ask questions about that then. And although I'm talking a lot about things that RISCV Foundation has been doing or that RISCV members have been doing, I'm talking kind of on my own behalf, so don't take anything as an official RISCV Foundation position. And this is, by its nature, it's a short talk. I'm trying to give a kind of a broad overview of what's going on. Feel free to chat to me afterwards if you want to know any more details about anything in particular. So, first of all, what is RISCV? Now, how many people in the audience aren't familiar with RISCV already? Is there anybody who is, yeah, Clifford gets struggling to get his mind around it, I can see. Yeah, so I think we're kind of reaching a stage now where, like with any computer architecture presentation, it starts with an unnecessary slide about Moore's law. It seems to be getting to a point where a lot of these presentations start with an unnecessary slide about RISCV, which is kind of nice. That shows that people already know what it's about, but we still kind of feel that you have to say something about what it is. So I'll be talking about kind of recent developments primarily. So fundamentally, RISCV is a freely implementable instruction set architecture. A key point is that it is an open standard. RISCV is itself not an open source core, though there are many open source implementations that you'll be hearing about this weekend and will have heard about for the past 2 or 3 years at ORConf presentations or elsewhere. I think this point about an open standard is kind of important, as that's what we've lacked an open standard that's had industry adoption and some sort of critical mass in the architecture world. There's obviously been OpenRISC. There's been Spark as V8 as a international standard, but they doesn't seem to have been as successful in getting a large group of companies around it. Now, RISCV itself the standard is managed by a not-for-profit industry consortium, the RISCV Foundation, and that is made up of a range of members. This list is now out of date. There's a bunch of extra ones now. Samsung's a member, Cisco, others which aren't on here yet. You can see the full list on the RISCV website. And so the way the RISCV Foundation works is that companies pay a small annual fee, which gives them the ability to vote on certain decisions, take part in board membership elections, and to use the RISCV trademark in their work. However, anybody can implement RISCV as they want to, and if you're a not-for-profit or an academic institution, you can still use a trademark for your open source work without kind of paying to become a member. Now, I guess with this audience, I think we're pretty much all on the same page about why you might want to have an open standard. But the reason, just to kind of underline the point, we can see where perhaps current players who are sitting on kind of the incumbent standards, which are very difficult or impossible for others to use, have been kind of like to make noise about how the difficulty of using that standard. So I thought this was I don't know if it was earlier this year, it was an amazing blog post on the Intel website, written in the most passive-aggressive tone possible, basically not quite calling out by name Microsoft and collaborators who are working on dynamic binary translation from x86 to ARM, but listing kind of a series of companies who have tried to do similar things and then got sued out of existence, or now no longer exist, partially due to legal issues. So I mean, this is why you can't just go and implement whatever instruction set architecture you want. We need to have some sort of standard which doesn't have this issue of patents which restrict you from going ahead and implementing it. I think we're also seeing kind of, at least at conference talks and the like, established industry players now seem to at least be talking the talk about open source being interesting for the for the industry. So it's not just the open standard that's interesting, but I mean players like NVIDIA talking about open sourcing some of their neural network related hardware. And I think the due date for that actually was around about now. It is, yes. I think September, that squiggly thing says. So we'll wait and see if that happens and what the whether open source meets our definitions of open source, but that should be interesting to see. So as I say, I just wanted to give primarily an overview of some of the technical work that's been going on at the RISC-V Foundation, I think, and with RISC-V members. I think everybody is somewhat familiar with the very basics of the RISC-V ISA, and people seem to want to know kind of what's been happening recently. So first of all, the ISA specification itself is an openly licensed document, and it's up on GitHub. I wanted to underline that because it wasn't true at the very start. So it wasn't clear how people could go and contribute to it, even if it's simple things such as cleaning up grammar in English or fixing typos. Anybody can go onto GitHub and fix up these sorts of issues for larger. I mean, if you want to go and add large new instruction set extensions, then that's obviously a GitHub pull request. The GitHub pull request isn't really going to be the right way to do that. You'll want to discuss with RISC-V Foundation members and try and get other people interested. But for simple changes, that's a very good way to go. A bit louder, yes, good. And more recently, there's been an effort to try and more clearly specify the processor-specific ABI. So the calling convention details about stack layout, ELF relocations, basically everything that you may not want to know about may not want to know about the precise details as a software author, but you want to know that everybody's conforming to the same thing, because otherwise your libraries aren't going to link together properly. They're going to have calling convention issues, and I think this is an area where we could definitely do with more contributors. There's a issues list there of things which are perhaps not as clearly specified as they should be. I think currently the de facto standard is basically whatever GCC and the GNU linker come up with, but that's not necessarily really the way going forward. And the document's improved quite a lot over the recent months, so you can read that and get a pretty good idea of what the calling convention is and various ABI standards and the like. So how the RISC-V Foundation works is that it's kind of split up into a number of working groups which involve the companies or individual members who are interested in that area. So those working groups then have a series of meetings, come up with a draft specification or a specification proposal, and it then goes to the technical committee, which involves all of the member companies, the voting members on that, and can then choose to accept it as a proposal, or possibly they vote to recommend it for acceptance, and maybe there's a final vote approval from the board of directors. So just to kind of summarize recent efforts. So for those of you who've been following the recent RISC-V workshops, I think at least last November's workshop, Krista presented on the vector ISA specification. There may have been updates in the last workshop in China. So most of the vector work is actually public. So on this previous, on the RISC-V ISA manual, you can find a draft of the vector ISA specification, and that alongside Krista's previous slides detailing it should give you a good idea of the kind of direction people are heading. So the model that RISC-V is moving towards for vector is a kind of support for variable length vectors. So rather than encoding the vector length directly in the ISA, it's kind of a property of the data that you're accessing. So it's a kind of Cray style vector ISA, and kind of somewhat similar to what ARM have now come out with the scalable vector support in the last year or so. Another kind of very important effort for those of you who are interested in Linux capable systems is pinning down the RISC-V memory model. So people who've read the current RISC-V specification, you'll see that there is a section on the RISC-V memory model, so looking at the semantics of atomics, and for the ordering of memory accesses. There's been some work from various researchers and industry collaborators who've kind of tried to apply various tools to verify that model against the requirements of the C11 and C++11 memory models, and have found that there are perhaps a few holes that need to be tightened up. And so the memory model working group has kind of got a lot of those players together and have been looking at a kind of cleaned up version of that. And so I kind of asked the major players for what I could say about a status update here. So my impression, I initially had the wrong impression that so there are basically two camps. Some people are preferring to stick with something that's as weak as possible, so it has very few ordering requirements on the hardware, and so that's quite similar to what was outlined in the previous RISC-V specification, and the model would probably end up being very similar to the ARCH64 memory model. There's another camp who are wondering, is the extra hardware cost that much of a big deal? Wouldn't it be much more straightforward for software developers, compiler writers, and everybody else who's trying to reason about a system if we went with something like TSO as used on x86, which has a stricter memory ordering requirements? And I thought that argument kind of died down, but it seems it hasn't. So there's, and this is actually somewhere where, so MIT have, so the current state is that people are looking to try and pin down all the details of the weak memory model, because then that can be used as a comparison point for discussions about something that might be a little bit stronger. And so MIT are just starting to spin up an effort to look at performance comparisons of the proposed weak model versus TSO. So if that's something that anybody's interested in, then that might be a way to get involved. And of course, we have a talk tomorrow which is looking at sequential consistency on low risk, which is very relevant to all of this. The debug specification is, I think, basically almost done now. It's kind of the one which is closest to the kind of ratification. So that's had that kind of started out being developed more out in the open, and then it was developed kind of more inside a internal RISC-V working group, but it seems to be reaching the point where people are agreeing now, and it's still the case that you can find the kind of draft specification on GitHub on the RISC-V GitHub organization. So debug specification is currently just focused on run control debug, the sort of things that you might need to support GDB or for bringing up a system. There's interest from multiple parties in looking at trace debug, but people want to start with kind of the basics first. The privilege specification, there was a recent draft update a few months ago, and I think Andrew's just about to put out a draft update of a hypervisor specification. So I think that's kind of, and people expect there won't be any breaking changes from this point on, so that's kind of rapidly reaching maturity. With the formal specification, well, there are a number, I think that group's just kind of spinning up, and it's bringing the main people together who have different approaches of doing a formal specification of RISC-V, and we'll hear more about part of that from Clifford tomorrow. So as you are hopefully aware, there are now shipping available RISC-V ASIC designs, so you can buy a Hi5 microcontroller dev board from Sci5. There's also a plethora of open cores and SoC designs. I think a number of these will be hearing updates on this weekend. So SCR1 more recently from Syntacore, which is very exciting. The Pulpino, Clifford's Pico RV32. I kind of have to give a plug for the Cambridge Computer Lab. We have, last year an intern kind of did a small RISC-V design mainly for teaching purposes that may be of interest. And of course, many of us are building on top of Rocket as a base design. So, these Pulpino, Pico RV32, Clavi, Orca, and I think the SCR1 are primarily focused at kind of microcontroller class workloads, whereas Rocket is, although it can be configured to for microcontroller class workloads, also supports MMU, paging, virtual memory, and everything you need to run Linux. And of course, there's now various proprietary offerings from different RISC-V members on the market. So to give a brief rundown of where we're at with software, so there's actually quite a lot which is now available upstream, so you don't need to use a kind of downstream repository and worry about whether that's up to date with all the latest changes. So that's true of GCC, binutils, and GDB. It's also, GCC and binutils, probably not GDB yet, I think. It's very recently become true of newlib, which is great because now you can build a cross-compiler using only upstream tools, which is nice. I recently shared a very simple recipe for a quick and dirty way of doing that without going through the painful multi-stage GCC bootstrap process. glibc and Linux kernel are somewhat interlinked, as I think the glibc developers like to wait until the Linux kernel support is in there before formally accepting things. Certainly the Linux kernel patches have gone through a number of revisions of upstream review. They're almost kind of ready for merging. LVM and Clang, I've been doing a lot of work on that recently. I'll be talking more about that tomorrow in my low risk talk, but there's a reasonable portion of kind of machine code level layer support already upstream, and code generation should hopefully be up there soon. There's also various simulation choices, so QEMU, Gem5. Gem5 is upstream. QEMU is currently downstream, but there's a new maintainer who's working hard to get that sorted. There's FreeBSD and a range of operating systems for RTOSes or more specialized operating systems like SEL4 that are available. I think there are some projects that are looking for more help from people, like a port of the Go language that was started by some Googlers maybe about 12, 18 months ago. I think they're looking for more help, and there are some people who are interested in Rust, which is somewhat predicated on the LVM work I'm doing, but I think some of us are kind of working together on both fixing the LVM requirements and working on the Rust port. So I expect we'll see something there by the end of the year, or possibly sooner for a very simple demonstration. And finally, the 7th RISC-V Workshop is going to be held in California at the end of November. People who want to present something, the submission deadline is the middle of next month. And registration is now open, so you can, the middle of this month, indeed, yes, because we're now September, yeah. Thank you. Yeah. So I think that's, as I say, a total whirlwind tour of recent things that have been going on. If you want to get involved, you want to know how, you can chat to me for pointers. I can point you to the right person. There's also a series of open mailing lists on the RISC-V website focused on either software development, on use in teaching and education, hardware development, and various others. So are there any questions right now?
Any verification reports?
Yes. So I think that so there's the formal work, and there's also a compliance working group, and their work is somewhat interrelated, but not completely. So I haven't heard much from where the compliance group are, but there is definitely lots of interest in that, and there should be, with the formal work spinning up, there should be more work between those two groups. So Trace hasn't really kicked off yet. So I think so a number of us, so Stefan and one of the Ultrasoc engineers, Gaj, we discussed just the kind of very basics in terms of what's the minimal amount of signals that you'd want any RISC-V core to expose for in order to insert your own Trace debug infrastructure. It remains to be seen how standardized we'll end up when it comes to Trace. I mean, it's taken a bit of a while on run control, which you'd hope would be more straightforward. So we'll see. I think is there a talk on OpenSock debug?
Yes.
Yes. So that's is one kind of Trace approach that some of us in the RISC-V community are adopting. So low risk adopts OpenSock debug. So I think, yeah, as I say, because it's been somewhat gated on the run control work, we don't really know yet exactly where we'll end up.
I have a question about debug. Yeah, so the debug working group
Yeah.
was formed quite a while ago,
Yeah.
and they made a kind of promise to the community that they would get it done. I don't know, I think originally it was the start of this year or something like that, and it's taken a lot longer. And the model, as you mentioned before, has been quite different to some of the other extensions that have been proposed. What's the view of the foundation on whether that's a good model or not? Because it's taken a long time to get anything. Actually, it looks like they're just going to deliver pretty much what they were going to do in the first place, but it's taken about a year to get there. Are they going to do other extensions in this manner, or are they going to change the model?
I mean, I don't know what the view of the foundation is. You can certainly observe that the debug working group started with a public mailing list and then went closed doors. That doesn't really seem to have accelerated the effort from what I can see, and that happened quite a long time ago. So difficult to say. I think that everybody's looking to try and optimize how these working groups work. So I think the debug was perhaps the first one that was tried, and maybe, and I think different working group chairs and different sets of working group participants kind of run the efforts in slightly different ways. So I suppose over time people will find something that works well. I think the debug work has taken quite a long time.
I was wondering, like, what's your thoughts on like IP violations when people try and implement RISC-V?
As in infringing on other people's patents?
Infringing, yeah, like other processor architecture patents.
Yeah, so I think the biggest risk would be implementation approaches that infringe other patents. So the RISCV Foundation maintains that they have a kind of RISC-V genealogy project, which at least when it comes to basic ISA features, that kind of goes back through the past, I don't know, 50, 60 years of computer architecture and picks out prior work that's kind of long past any patents could possibly cover to point out that for each of these instructions, here's prior art. For the, when it comes to microarchitectural techniques, I think it could be that other RISC-V member companies become interested in doing something similar for that. That hasn't happened so far. And on the other hand, look at the kind of MIPS cores from 20 years ago. They're already pretty advanced with a lot of microarchitectural techniques that we rely on today, and patents are expiring on those. So I think there's plenty of advanced microarchitectural techniques that you can look at. The textbook examples of a superscalar design are basically out of patent now. So I think you can have a reasonable degree of safety.
Thanks.
Do this. My impression is that it's ramping. I mean, anecdotally speaking to people, people from industry, like there was the ARM Partners meeting in Cambridge a while ago, which is great for us RISC-V people too, because everybody comes to Cambridge and then we can go and have dinner with them and catch up and so on. And the impression there versus the previous year was that kind of before there were lots of these companies who were looking at RISC-V and trying to take a bit of a wait and see approach. Now there seem to be more who perhaps haven't committed to a design start, but have at least one or two groups who are trying to secure internal funding for projects that would involve a RISC-V core in some way. So I definitely get the impression that things are ramping up. Okay. Great, thank you very much.